Good morning, students. So, in the last class, we were discussing about the pH. About pH. What is pH and its definition, and what is pH and all we studied, and we know that we can also check the pH of different substances, different solutions, and different acids, bases, etc. And we know the pH range. The value of pH is 0 to 3. If the value of the pH is 0 to 3, that is they are strongly acidic in nature. They are strongly acidic in nature. And the value of pH, the pH value is 3 to 6. They are acidic. They are acidic in nature. And 6 to 7, they are weakly acidic. They are weakly acidic in nature. And the value of, if the value of pH is 7, the value of pH is 7, that is what? It is neutral. That is water. Pure water is having 7, that is it is neutral in nature. And the value of pH is 7 to 8 or 9, 7 to 9, it is weakly basic. It is weakly basic in nature. And the value is the value of 9 to 12, it is basic in nature. And if it is 12 to 14, it is strongly basic in nature. It is strongly basic in nature. So this is the value of pH in different solutions. That is in different the value as the value of pH changes, they having this type of, that is, if it is 0 to 3, it is strongly acidic. If it is 3 to 6, it is acidic in nature. If is 6 to 7, that is weakly acidic in nature. If it is 7, it is neutral. And if 7 to 9, that is weakly basic in nature. And 9 to 12, it is basic. And 12 to 14, it is strongly basic in nature. That is, 1 molar HCl. Molar, I told you that is the concentration can be represented in molar. 1 molar HCl is if pH value is 0. 1 molar NaCl, sorry, not NaCl, NaOH, sodium hydroxide, it is 14. pH value is 14. It means this is strongly acidic. It is strongly basic in nature. And we know the saliva, our saliva, before meal it is 7.5. The pH value of our saliva, human saliva, is 7.5. That is, it means it is weakly basic in nature. And after meal it is 6.5. It means they weakly acidic in nature. And then there are number of values. For example, that is lemon juice. Lemon juice is 2 to 3. Its pH value comes 2 to 3. And then coffee it is 4.5 to 5.5. 4.5 to 5.5. Tomato juice, that is 4 to 4.5. This is approximate value of the pH values of different solutions are there. So anyway, this is the pH. We have studied what is pH. It is the negative logarithm of H plus ion concentration. Negative logarithm of H plus ion concentration. And these are the pH values of different solutions. Okay. Next, we are going to discuss about what is the application of this pH. How pH plays a role in the everyday life, in our everyday life. The first one is that pH change, pH in our digestive system. pH plays a major role in our digestive system. We know we take food. After taking food, it reaches in our stomach. We know in stomach that the walls of the stomach, it produces an acid, that is hydrochloric acid. The walls of the stomach produces hydrochloric acid. It is strong acid, hydrochloric acid. And this acid, it catalyzes the action of enzymes like pepsin enzyme that is produced in our stomach. It catalyzes its action by keeping the pH less than 2, the pH value less than 2. That is this acid, and this acid helps in the digestion process in our stomach. And not only that, when food reaches through the alimentary canal into our stomach, it also may contain some some germs, that is microorganisms, disease causing organisms may be there, or germs will be there. So it kills the germs, and not only that, when sometimes in some people it produces excess amount of acids because of tension or some other process, that is high tension. It may produce more amount of acids in the stomach. So that may cause what? Acidity. That is called acidity. If the excess amount of acid is produced in our stomach, that may leads to pain in the stomach, and also that leads to indigestion. So the person who is suffering from indigestion, it can be cured by taking mild acids like milk of magnesia, that is magnesium hydroxide, that is milk of magnesia, or light solution of baking soda. So it can be cured. So it means what is happening there, because they neutralizes by taking these type of mild bases, it neutralizes the acid inside the stomach, and they get relief from this type of pain or indigestion. Okay, so that is the role of pH in our digestive system. Okay, and the second one, a number of applications are there. The second one is that the pH change, it may causes pH change may cause tooth decay. It may cause tooth decay. We know our saliva, human saliva, it is slightly basic in nature. I told you that its pH value is 7.5 before meal, but after having food, the pH changes. It may changes into 6.5. It means it become acidic in nature. And not only that, if we take more amount of sugar containing food, it may also leads to increase the pH value in the saliva. Saliva's pH value may increases. pH value pH value decreases means it become acidic in nature. That is, it may become 5.5 or 5. If the pH value is its value reduces lower than 5.5, it is very dangerous, because it will react with that that is enamel that is present in our teeth. Then it corrode it. That will corrode it. Then how these are producing, that is these sugar containing food, that is bacteria inside our stomach will it will act on this sugar containing food, and it decomposes and it produces acids in our stomach, and this acid will react, it will attack on the enamel of the tooth, that is then it will corrode it. So pH changes may cause the tooth decay. So what is happening there? What is the teeth? It contains enamel, that is calcium phosphate, Ca3 PO4 twice. It reacts with the acid HCl and it forms what? Plus this is called phosphoric acid. So these acids, it will react with the enamel of the enamel, that is the toughest part in our human body. So it will react with that enamel of the tooth, and then it corrode it. It will corrode it. So that is pH change will it will adversely affect the teeth. That is, it may cause to what? Tooth decay. And then is plants and animals are sensitive towards pH change. Plants and animals are sensitive to pH change. How they are sensitive towards the pH change? We know our human body, they works on between the pH range of 7 to 7.8. We know our blood is slightly alkaline nature, and its value is 7.35 to its pH value is 7.35 to 7.45. So if the pH is changing, then if the pH value of our blood or anything is changing, then it may adversely affect the the existence of the humans and plants also. If the soil is too acidic or too basic, the plant cannot grow properly. Plants cannot grow properly if the soil is too acidic or too basic. So, if the pH value of the soil is 7, then most of the plants, they grow properly if the pH value is 7. And we know that if the pH is too acidic, what we do? We are adding Slaker lime. Slaker lime, you know what is Slaker lime? That is calcium hydroxide. So Slaker lime solution into the soil. So we can neutralize the soil by adding bases. So in that way, if the pH is too acidic, it will not grow properly. If the pH is too basic, that also adversely affect the growth of the plants. So it is also a major role, that is pH change also sensitive to the growth of plants and animals. And then the fourth one is, a number of applications are there. Another one is that pH change, that is self defense. Self defense of plants and animals through by chemical warfare. Chemical warfares. Self defense of plants and animals by chemical warfare. We know when a honeybee stings on our body, it causes pain and irritation, isn't it? It causes pain and irritation. So what we do? We may by applying certain light or weak bases like baking soda solution, or sometimes we may apply what, turmeric, turmeric. They are bases. So it will neutralize because it may cause burn and pain. And the stinging leaves of stinging hairs of nettle leaves, it causes a pain. Why? Because they inject methanoic acid, or they inject formic acid into our body. That is why we feel we feel pain, and it causes burning, isn't it? It causes burning. Why? Because they inject acid that contain formic acid or methanoic acid. And even that is what the honeybees, they also inject methanoic acid. So in order to neutralize, what we do, we are applying certain mild bases, isn't it? So that is also what, pH change. So self defense of plants and animals by chemical warfare. So pH change, pH values, it plays a major role in our daily life, isn't it? So all, these are some of the applications of pH. So you can also quote many other examples. We have discussed only 4 here. Okay, I hope you understood all these things. Now we move on to the next topic, that is salt. Okay. Salts. So we have studied about acids, bases, and then next is salt. And when we are studying about the actions of acids and bases on metals, on carbonates, bicarbonates, etc., there we studied that we will get salts by the action of, that is neutralized, by neutralization reaction we may get salt, isn't it? By the action of acids on metals we get what? Salt plus hydrogen. And by the action of bases with by the action of metals with the bases we get metal salt plus hydrogen gas. And then by the action of acids on carbonates and bicarbonates we get what? Metal salt, carbon dioxide and water, isn't it? So by all these processes we get what? Salts. Now let us discuss some of the general properties of the salt, that is families of salt. Some common terms, families of salt. Families of salt means, for example, Na2SO4, K2 NaCl, NaCl, Na2CO3. See, in this case you can see sodium sulfate, sodium chloride, sodium carbonate. In all these cases there is a common thing that is called as sodium. So common cations are same, that is sodium is same. So this or belongs to a family. Why? Because they contain a common cation, and then KCl, NaCl, CaCl2. See, this is potassium chloride, sodium chloride, calcium chloride. This is also a family of salt. Why? Because in all these cases it contains a common anion. So this belongs to a family, this belongs to a family. So this is called the families of salt. Okay. Now next, so hope you understood what is families of salt. If it contain a common cation, they belongs to a family. If it contain a common anion, they belongs to a family. Okay. Then types of salt. Types of salt. On the basis of the aqueous solution of the salt solution, we can classify the salts into acidic salt, basic salt, and neutral salt. on the basis of the pH of the salt solution, we can classify salts into acidic salt, basic salt and neutral salt. So, acidic salt means if the pH of the salt solution is less than, pH value is less than 7. If the pH value is less than 7, that is called acidic salt. And if the pH value is greater than 7, pH value is greater than 7, that is basic salt. And if the pH value is equal to 7, it is called a neutral salt. So, on the basis of the pH of the aqueous solutions of the salt solution, we can classify salts into acidic salt, basic salt and neutral salt. And in a salt, there are two, is very important, that is in a salt there are two substances, that is called a basic radical and acidic radical. In a salt, there are two types of substance, that is basic radical and acidic radical. Basic radical, cations are generally called basic radicals, and acidic radical, that is anion. Anions are called acidic radical. Why? Because they are obtained from acids. And why cations are called basic radical? Because they are obtained from bases. That is why they are called basic radical and ionic radical. Okay. So, basic radical, ionic radical. And here I told you that acidic salt, as how these acidic salts are getting, they are obtained from, acidic salts are formed by the reaction between strong acid and weak base. Acidic salts are obtained by the reaction between strong acid and weak base. And basic salts are obtained by the reaction between strong base and weak acid. Acidic salts are obtained by the reaction between strong acid and weak base. Basic salts are obtained by the reaction between strong base and weak acid. And neutral salts are obtained by the reaction between strong acid and strong base, or weak acid and weak base. So, acidic salt, they are obtained by the reaction between strong acid and weak base, and basic salt, they are obtained by the reaction between strong base and weak acid, and neutral salt, they are obtained by the reaction between strong acid and strong base, or weak acid and weak base. Okay. And I have already told that when we were discussing about the strong acid and weak acid, strong base and weak base, I have given many examples for that, and I will give you some examples for this. For acidic salt, examples are ammonium chloride, ammonium sulfate, magnesium chloride. All these are examples for strong acid. Why? Because see, we know this is the cation and this is the anion. Cations are formed from bases and anions are formed from acids. That is why anions are called acidic radical, cations are called basic radical. So, here what will be the base here? NH4, that is ammonium hydroxide, isn't it? Ammonium hydroxide will be the base. And then what will be this is acidic radical. Acidic radical is formed from acids. So, here it will be HCl. So, HCl and ammonium hydroxide, what we get? We get ammonium chloride plus water. Ammonium chloride plus water. So, that is why what they are formed between, it is an example for acidic salt. Why? Because it is formed from strong acid. HCl is a strong acid, and it is formed from strong acid and weak base. Ammonium hydroxide is a weak base, isn't it? And take another example, ammonium sulfate. Ammonium sulfate means it is formed between ammonium hydroxide and sulfuric acid, H2SO4. H2SO4 and ammonium hydroxide, we get what? So, H2SO4 is a strong acid, ammonium hydroxide is a weak base, we get what? Acidic salt. Then magnesium chloride, it is the reaction between magnesium hydroxide and hydrochloric acid. Magnesium hydroxide is a weak base, and HCl, it is a strong acid. We get magnesium chloride. Then basic salt, example for basic salt are sodium carbonate. Here sodium carbonate, for one example I will give you sodium carbonate. See, sodium carbonate, here this is the basic radical. So here we get sodium hydroxide is the base, and here this carbonate is coming from H2CO3, that is called carbonic acid. This carbonic acid is a weak acid and sodium hydroxide is a strong base. So by the reaction between strong base and weak acid, we get basic salt. Another example, that is basic salt. Another examples are sodium CH3COONA. This is another example, that is called sodium acetate. Here CH3, here the acid will be CH3COOH, that is called acetic acid and sodium hydroxide. Sodium hydroxide is a strong base, acetic acid is a weak acid. By the reaction between weak acid and strong base, we get what? Basic salt. Then neutral salt, a number of examples for neutral salt, that is NaCl, NaNO3. See, NaCl is obtained from strong acid HCl and strong base NaOH, and here NaNO3, that is obtained from the strong acid HNO3 and sodium hydroxide, isn't it? And then weak acid example, another example, weak acid, CH3COONH4. CH3CO, that is called ammonium acetate. This is called ammonium acetate. It is formed by the reaction between acetic acid and ammonium hydroxide. Ammonium hydroxide is a weak base. This is a weak acid. So by the reaction between weak acid and weak base, we get ammonium acetate. So ammonium acetate is a neutral salt, and sodium chloride is a neutral salt because it is formed between sodium hydroxide and HCl. NaNO3, HNO3 and sodium hydroxide, we get NaNO3. All these are neutral salt. Okay, so these are the different types of salt. So I hope you understood all these concept, salts, types of salt, how we are getting acidic salt, how we are getting basic salt, how we are getting neutral salt, examples for neutral salt, examples for acidic and basic salts. Okay, we will discuss in the next class. Okay.